Dear students, in this video lecture we are going to discuss GSM architecture, that is Global System for Mobile Communication. So before moving towards the different blocks of the GSM architecture, we will discuss few points related to the GSM. So GSM, that is Global System for Mobile Communication, is a second generation cellular standard developed to provide the service, that is voice and data service using digital modulation. So the standardized system had to meet the certain criteria. So here the first criteria is the spectrum efficiency, so better utilization of the frequency band. The second criteria, that is international roaming. Third, low mobile and base station installation costs. Then good subjective voice quality, or we can say the improved voice quality, and ability to support new services. So new services can be added in the existing GSM network. So before moving towards the architecture of GSM, we will see the GSM network structure. So in this diagram we can able to see the honeycomb type of the GSM network structure. In each honeycomb we can able to see the antennas. So these antennas are responsible to provide the radio service or wireless link to the cell phones which are observed in the radio coverage. So in this GSM network structure we will find the cells, or we can say this GSM network structure consists of, the first one is the cell, or we can say the structure can be divided in cell, second location area, then mobile switching center service area, then PLMN, that is public land mobile network service area, and finally combination of all, that is cell, location area, mobile switching center service area and PLMN service area are included in GSM service area. So we will see one by one. The first one is the cell. So cell is nothing but the basic unit of the cellular system and is defined as the radio coverage given by one BTS, that is base transceiver station. So here base transceiver station is responsible to provide the coverage area with the radio or wireless link. So this cell is shown in hexagonal shape. The reason behind is to show the hexagonal shape such a way that the cell phones available in the coverage area should get the proper signal, but actually in the actual environment we are not getting this hexagonal type of coverage, the random radio coverage we are getting. So if suppose these cells get combined, or combination of these cells are nothing but the location area. So a group of cells served by one or more BSC, that is base station controller. So base station controller in GSM is responsible to provide the services to the BTS observed in each cell. So one or more BTS can be connected to the BSC. So this location area where the group of cells within a network, a subscriber location is known by the location area which they are in. The identity of the location area in which an MS, that is mobile station, is currently located is stored in VLR, that is visitor location register. So the information about the user or the mobile phone you will find in visitor location register. Then the next one, that is MSC service area. So MSC service area is nothing but the combination or group of the location areas. So an MSC service area is made up of the location areas or group of location areas. So here we can able to see the yellow, red, blue and green color honeycomb type blocks are connected with each other. So this MSC service area is nothing but the combination of the location areas and represent the geographical part of the network and controlled by an MSC. So here the base station controllers which are observed or available in location areas, they will communicate with the mobile switching centers. The next one, that is PLMN, that is public LAN mobile network service area. So this PLMN service area is the entire set of cells served by one service provider or network operator and defined as the area in which an operator offers radio coverage and access to its network. So here we can able to see the blue, red, pink color are shown on the map are nothing but the PLMN service areas. And then finally GSM service area, which includes all these points that we discussed, that is cell location area, MSC area. So here GSM service area is the entire geographical area in which the subscriber can gain access to GSM network. So here we can able to see the green color box indicates the cell get covered in location area, that the one MSC consists of one location area. Again this cell and location area included in MSC VLR service area, which is covered by one MSC. And finally all these, that is cell location area, MSC service area and PLMN service area, controlled by the service provider or operator's network. Now we will see some characteristics of the GSM standard. So this GSM network or GSM standard is fully digital system which is working on single and dual band, that is 900 and 1800 megahertz frequency. It utilizes the time division multiplexes over radio carriers with the carrier spacing 200 kilohertz. It consists of 8 full rate or 16 half rate TDMA channels per carrier. User or terminal authentication for fraud control. This is an advantage of this GSM. Encryption of speech and user data transmission over the radio path. So data and voice information security, we can say. Then full international roaming capability. Then low speed data service, which is up to 9.6 kbps. Then this particular GSM is compatible with the first generation ISDN, that is Integrated Service Digital Network. This you know very well, it supports of short message service, that is SMS. Then the advantage of GSM system, first one is the capacity increase in capacity due to the TDMA and the time slot, the number of customers with better service. Then reduced RF transmission power and longer battery life. So due to the low transmission power, improved battery life, international roaming capability, then better security against fraud or through the terminal validation and user authentication, encryption capability for user information, compatibility with the ISDN network with wider range of the services. Then we will see the feature of the GSM. The second generation of the GSM, which provides the 9.6 kbps of data rate. The next generation, that is 2.5G, it consists the HSCSD, that is high speed circuit switched data service. It is about 76 kbps, or we can say 9.6 into 8 channel, that is 76.8 kbps of data rate. The second feature, that is GPRS, General Packet Radio Service, which provides 14.4 to 115.2 kbps of the data rate. Then the next advanced feature of this 2.5G, that is Edge, enhanced data rate for GSM evolution with the data rate 547.2 kbps. Then the third generation, which is working on WCDMA, wide band CDMA. So here we are getting the data rate up to 2 Mbps, minimum 0.348 Mbps to 2 Mbps. Then we will see the services offered by this GSM. So GSM offers the first service, that is several types of the connections. So voice connection, data connection, and short message service. So both circuit and packet related services are offered by this GSM. Multi-service options are available. So combination of the basic service, the virtual and data packet related services are available. So 3 service domains are available. So first one is the telemetry service, which provides the voice and short message service. Then the data related services, and finally the supplementary services. So telemetry services, nothing but the telecommunication service, which consists of the voice communication via the mobile phones, the basic service. And offered services are the mobile telephony, emergency calling, and voice messaging, kind of the additional or offered services. Then the data services, which includes the various data services for information transfer between GSM and other network like PSTN or ISDN kind of network, with the data rate of 300 bits per second to 9.6 kbps. Short message service, voice mailbox kind of service, email service. So these are the data related services offered by the GSM. Then supplementary services like the call related services. So here you will find the call waiting. So call waiting is nothing but notification of an incoming call while on the handset. Call holding facility or the feature of the service. So we can put a caller on hold to take another call. Call forwarding. So call forwarding means we can forward our call to another number. So call can be sent to another or various number defined by the user. Multi-party call conferencing. So here multiple user can speak in conference. So link multiple call together. Okay, now we'll move towards the architecture of the GSM. So this GSM architecture is divided in two parts, that is NSS, that is network service part, and BSS, that is base station subsystem. So in this BSS you will find the BSC, that is base station controller, is connected to BTS, that is base transceiver station, and base transceiver station with the antenna or the tower where the antennas are observed. Then NSS, so in NSS you will find the mobile switching centers. So MSC is responsible to communicate with BSC, and so is responsible to communicate with the another network, that is PSTN, public switch telephone network. So MSC is working with VLR, that is visitor location register, home location register, authentication, EIR, operation and maintenance kind of blocks or services. So BSC and MSC are connected with A interface. BTS and BSS are connected by using ABS interface, and the wireless link between the mobile tower or BTS to mobile station MS are connected with UM interface. So these are the components of the GSM architecture. So first one is the mobile station or handheld device, that is mobile phone. Then BSS, that is base station subsystem, network switching subsystem, NSS. So about the mobile station or mobile phone, we know very well the mobile station is made up of the two entities, that is mobile equipment and subscriber identity module, that is SIM card. So mobile equipment, no need to explain about the mobile equipment or mobile phone. So it is a portable vehicle mounted or handheld device, uniquely identified by an IMEI number. So with each mobile we are getting the IMEI number, that is International Mobile Equipment Identity Number, a unique number. So by using this particular device we can transmit the voice and data. Also this particular mobile phone or mobile equipment is responsible to monitor the power of the signal and signal quality of surrounding cells for the optimum handover. The range of the power level observed with the depending on the type or cell phone, that is 0.8 watt to 20 watt. So by using the cell phone we can send the SMS with the characters of length 160 characters. The second part of this image, that is subscriber identity module, that is SIM card. So in this picture we can able to see different types of the SIM card, that is eSIM, electronic SIM, nano SIM, micro SIM and standard SIM card. The SIM card contains the International Mobile Subscriber Identity, that is IMSI. It allows user to send and receive the calls and service other subscribe services or the services which are offered by the service provider. So these SIM cards can be protected by using the password and the PIN number. So it can be moved from one phone to another phone. So we can insert the SIM card to one phone to another phone, which contain the key information to activate the phone. So the next component of the GSM architecture, that is base station subsystem. So base station subsystem consists of the two main blocks, that is BTS, base transceiver station, and BSC, base station controller. So here base station controller is responsible to provide the service or provide the service to the BTS. So this BSC and BTS are connected by using the different types of the transmission media, either the copper wire or the fiber optic cable or the radio link. So here we can able to see the first BTS is connected to BSC by using wireless link or radio link, and second BTS is connected to the BSC by using copper wire or fiber optic link. And BTS is responsible to provide the wireless service or the coverage area. Depending on the power available with the BTS, we are getting the coverage area where the mobile phones available in the network get connected by using UM interface. So as I said, it consists of two major hardware components, that is base transceiver station BTS and base station controller. So about the base transceiver or transceiver station or BTS. So in this picture we can able to see the BTS, a tower which consists of the transmitting and receiving antennas, and the BTS power source is connected to the particular section. So BTS contains the RF component that provide air interface for the particular cell. So this BTS encodes, encrypts, multiplexes, modulates and feeds the RF signal to the antenna. So it communicates with the mobile station and BSC, that is mobile phone and base station controller. And as I said, this particular BTS consists of the antennas which are responsible to provide the wireless service. So it consists of the transceiver units and the TRX units. Then the base station controller. So in this picture we can able to see the typical cards which are available in the BSC, or we can say a rack type arrangement. So it provides the control for the BSS, that is base substation. It communicates directly with mobile switching centers. So BSCs will communicate with the mobile switching centers. It may control single and multiple BTS. So sometimes it is observed that a single base station controller is connected with the number of BTS. So in charge of handover, so during the handover process, the frequency hopping, exchange function and control of power level of BTS with the help of this BSC. So BSC is responsible to take care about during the particular handover or handoff procedure. In the next part of the architecture, that is network switching subsystem. So the network switching subsystem, as we discussed, the different blocks observed, that is HLR, VLR, AUC, EIR, MSC. So these are the functional units of the NSS Mobile Switching Center: Home Location Register, Visitor Location Register, Authentication Center, Equipment Identity Register, EIR, Operation and Maintenance Center, OMC. So first of all, the mobile switching center. So here we can able to see the typical arrangement of the mobile switching center. So this mobile switching center is the central component of the NSS network switching subsystem. MSC perform the switching function. So each MSC provides service to MS or mobile phone located within the defined geographical coverage area. So if suppose one of the mobile is changing its location from home location to another location, so at that time the BSC will communicate with the mobile switching center to tell about the particular mobile phone or mobile station is changing its location or moving from home location to roaming location. So at that time the mobile switching centers will communicate with the another mobile switching center to hand over the services to the particular cell phone. So during that particular period, home location register or the contents or database available with the HLR and VLR are utilized. So this HLR stores information about each subscriber that belongs to its MSC in permanent and temporary fashion. As soon as mobile subscriber leaves its current local area, the information in the HLR is get updated. So the database consists of the IMSI number, prepaid postpaid number, roaming restrictions and other supplementary services. Visitor location register. So this VLR contains the information about the subscriber parameters and location information of all mobile subscribers currently located in the geographical area controlled by that particular VLR. AUC, that is authentication center. So it is used for security purpose. Okay, so authentication is a process to verify the subscriber SIM or to check authenticate user is there or no. AUC and HLR collectively authenticate the subscriber or the mobile station. Equipment Identity Register, EIR. So this EIR consists of all device related information and identifications registered for this network. So the database that is used to track the handset using the IMEI number. So it provides the white and valid list, grey and monitored list, and black and prohibited list. Then Operation and Maintenance Center, OMC. So this particular OMC is responsible to provide the service related to the maintenance and diagnostic. So this diagnostic heart of the base station subsystem. So it allows the network provider to operate, administer and monitor the functioning of base station subsystem.